electron pushing, here's somewhat of an example, I guess. You can't, one thing is you can't push electrons so a carbon's going to have more than 4 bonds. Like, you can usually, if you have double bonds or lone pairs, that's when you can push. So I could push these electrons this way, that double bond could kick here, and that could kick up. So then I would be left with this guy here, positive charge, because now, but I wouldn't be able to push it the opposite way. Because if I go this way, this carbon already has 2 hydrogen bonds. So if I ended up with a double bond here, I have, I have hydrogens there. As well as now this oxygen doesn't have this octet rule. Well, I guess that's fine, positive. But this couldn't happen. Carbon's not going to have more than 4 bonds. That's one thing to look for. So generally, things that can accept a double bond coming up would be like an oxygen or a nitrogen. Usually can accept another lone pair. So while we're on that topic, let me draw some of these. CH3 and that's lone pair then.
So back to 106.
A little bit. I think it makes it easier though. So if I'm going to, let me draw it this way. If I'm going to push electrons, one thing I notice here is I have 2 lone pairs and I have this double bond. So those things can push. One thing you can't do, I can't move this double bond or that lone pair there, because now carbon will have more than 4 bonds, so I can say, okay, that can't work. I could move this one here. I can go that way, which will give me a triple bond here. And then all you gotta do is think of formal charge. 1, 2, 3, 4. 5 minus 4 equals 1. 1, 2, 3, 4, 5. So now we have a positive, and then now this guy is neutral. So you gotta ask yourself, is that more stable than this one? Both are nitrogens, so it probably doesn't really matter. These are probably equal in stability.
Can we look at this? Sorry. Well, this was just like the acid-base one, and I get this formal charge wrong because so I thought there was a carbon here, and so it would be 1, 2, 3, so it'd be positive, but it was a negative charge here. So the hydrogen came off from this.
Your thing is, there you have a carbon there. You don't have a carbon there.
You don't?
Yeah.
So what's there?
The hydrogen. That line is showing that it's bonded to the hydrogen.
The hydrogen left.
Yeah, let me draw that. Something like this, right? So when something steals this hydrogen, the way you gotta look at it when you're pushing electrons, this grabs the hydrogen. These are just electrons between this carbon and the hydrogen.
Mm-hmm.
So those are gonna go to this carbon. So now you have a negative
So
charge
that
there.
line is not necessary?
It's a bond.
This one?
Here it's showing it's a bond between the hydrogen and the carbon. So with the hydrogen left, there's no bond there.
So you would have brought the lone pair here up to the carbon?
Yeah. Count number of carbons when you're doing this, because a lot of people get that mixed up. A lot of people think, oh, I have, let me just draw something. Like this, a lot of people, if I have this structure, a lot of people think I have 1, 2, 3, 4, they have 4 carbons, 1 oxygen. but let's say I remove the oxygen, a lot of people still draw this. Well, now I'm saying I have 1, 2, 3, 4, 5 carbons. So make sure you don't add an extra carbon when you remove something.
Then why is it still negative though?
It's negative because the carbon has 2 hydrogens.
It had two.
So I have 1, 2, 3, 4, 5. 4 minus 5.
Okay, so that's what I got wrong. So it'd be 5 and then.
So Brian, then the other thing you do with this one here is you could also say, what if I move that lone pair? So now I have,
We got Ethan Peachman.
you'd say that. But then this wouldn't fit the octet rule.
No.
So when you push electrons, look for octet rule and make sure you don't add bonds towards the carbon.
And so if you can't push it, then
Then it won't
Like-
push.
I mean, right? But like if you've already done a couple of structures and then you can't push it anymore, then that's it. You don't have any more.
Yeah, just go back to your original and see if you can push it another way. What is this one?
And I've heard it said that no matter what, get charged off of carbon as fast as it can. And pretty much
Yeah.
that would be a good safe rule to say
Yeah.
which is more stable or which contributes more.
And like this example here, when I got that negative charge there, well, I guess if it would look like this, if I had a negative charge here, this will probably kick down and kick up. Because here you have a negative charge on a carbon.
Yeah.
If I form this guy here, now my negative charge is on the oxygen.
Which is more electronegative, which would be
More
better
stable. Yeah.
resonance.
Now if I gained a positive charge on that carbon, it'd be better for the carbon to have a positive charge than the oxygen to have a positive charge. So,
Okay.
and oxygen's not gonna have a positive charge. Well, the only way oxygen can have a positive charge is if it picked up a hydrogen.